Anyone watch these live streams on YouTube?
I
Generally,
do.
really?
I do actually, yeah.
Well, especially when I went over all those questions the other day, that was a good time if you missed class. Watch the live stream. Okay. Where's my thing? Oh no. It's my black, I think. Okay. Let's see what we got going on. So today, we have nothing due, but next time we will have due will be error. So I'll look at those and see if you did anything with the error, and then quiz 6 is due next time.
You're not sharing the screen.
I am not sharing the screen. Thank you, Eric. All right, so here we go. I wasn't, so anyway, let me just say, so with respect to notes, I'm concentrating. Notes. I did L'Hopital's rule and 0 times infinity last time. I'm going to do analysis of functions today. All right. Next time, next week, we will have optimization and indefinite integrals, and that will be the end for the midterm. Then you have the midterm. I think it's like Halloween or something. The midterm is, oh, look at that. Just in time for you to go trick-or-treating. It's a few days before Halloween. Okay. Yes, sir.
Why do you keep them exams and tests on the weekend?
Because that's the way they were.
I'm just asking. I'm just curious.
Okay, here's why I do it on the weekend, if you really want to know. Because I don't stop for the tests. So you have these modules to keep doing, and they're due on Tuesdays. So I want you to get the tests done and then stop a few days to get to the modules. That's why I put them on the weekend. If I put that on a Tuesday or whatever you want, if I do too close to Tuesday, you won't do that module at all. You'll do the midterm, you'll smoke a cigarette, and then you'll be exhausted, and you won't do anything for the next mod. So it has to be earlier. But I also don't want to do it today. I want to do it like Thursday or Friday because that's too close. So I make it Saturday, Friday, but that's why I do it. But I also ask at the beginning if anyone has any problems with those dates. So you should tell me if you had problems with them. Because there they sit. There they are. But if I was going to do anything, I usually do, if I gave more than one day, which I have done in the past, it would have been Friday and Saturday. It would never be a weekday or Sunday. Sorry. Thank you for asking. I'd forgotten. Nobody asked that question. But there are some people, are you one of those people who works all weekend? Yeah.
Because we all work on Saturdays
And Sunday.
and Fridays.
Would you have anything? You must have a morning or an evening. You can't work all day.
I mean, it's like 12 to 8. Gotta figure out something. And on
Yeah,
Saturday,
It's the morning
10.
or after 8, from 8 till midnight, because it's you have 4 hours at night. And you have all. You do it. If you're like me, you would stay up Friday night and do it at midnight because it opens at midnight. There's 8 hours of the day that's not. You can take it. But you have to be why that works for me is because I'm a late night person and I stay up late and I study late. I'm doing my work late so that it's actually good to take the exam the way you study for things. So if you prepare in the morning, then you want to take the exam in the morning. So I would take it late at night. But if you're a late night person, midnight is fine. Most guys said, do you really go to bed by midnight? Do you? It's a night class. When I teach this class, I gotta come and eat something. I'm hungry. And they say you shouldn't do that. but I have not, I've been doing these night classes forever, and I know that you're not supposed to eat when you go home. And the longer I wait to eat before I go home, the more likely it is I'm gonna binge at like midnight or something. Like, if I don't eat right away, I will eat later. I cannot just go to bed on an empty stomach after this class. Yeah, so anyway, so you're probably up late. I'm sorry, but it's a night class. I don't have any solutions for it. If you find you have a solution, let me know, but that's what I've been doing for years, is saying, I'm just, after class, I'm gonna go home. I'm not gonna eat. And what do? I usually scarf food in the car, and then when I get home, I still eat it. So I stay up till 2. So that's when I would take the test. And then I stay up till 4 because then I can't get to sleep because I just took a test. So sorry about that. All right. Everyone okay what we're doing? So that's the midterm. It's going to be up to and including what's called indefinite intervals. And then after that, everything after that has to do with integration, and it's not that bad. Also note, there is not an integrals test. There's a project instead. So that test is gone. All right. Any other questions on this? Let's go to lessons and see what we got going on in Mod 6. Today's Mod 6, which is L'Hopital's rule and analysis of functions. Let's see what you guys did for your discussions. It's weird to me that this does this every time. Okay, fine. Did you Slade? Did I call you before? Did I call you before? Slade, maybe I did. Okay, so this is the error one. You picked 2 salaries, 75,000 and 100,000. Okay, I want to say this about, I just want to make a point here. If you're looking at the slope of the tangent line at 100 right here, that looks pretty substantial, right? I mean, it looks like something, maybe 1 or 2 or whatever. But look at the number you have, 0.03. That's like not a person. Like you're saying at 100,000, I have 5 people plus or minus this tiny number. Why? Why does that number not look like this graph? I mean, I would understand if it was up here because that's close to 0, right? But why is that not close to 0? Well, here's why. I'm going to tell you a story. When I was in PChem lab, I remember this woman I had she was my lab partner. She had data points that looked like that, those 3 data points, and she had a line that went like this. Does that line look like to go through any of those points? No. But then she changed the axis and zoomed out. So now the points look like this. So when you zoom out, you get that. Do those look like they might go through there? Better. The further out you go, the more they look, the better it looks. The reason why your graph doesn't look like a 0 is because these are 50 and 100. Each one of these spots is 20. So your y-axis is changing by 20, each little block. Here, they're rising up by how much? 1, 2, 3, by 0.25. Okay, so this graph here is basically, if you just did 1 block, it would be 0.25, which is the rise over the run, which is 20. So what looks like a slope of 1 is actually a slope of 0.00 something. I don't know, 0.25, it's 0.0125. 25. There it is. I think it's that, 0.0125. So that slope like that is close to 0 because of the way you chose your axis. That's all. So why do we need calculus then? Because you don't want somebody jerking you around by showing you a graph that looks like your business is making a lot of money. Invest. This cryptocurrency is really going to pay off. Look at how well it's doing here. Look at our graph. We are really skyrocketing now. But if you look at the axis, you start to realize no. Or if they give you the rate that they're paying, they say, oh, our payoff is 5% per 1,000. So 5% already means divided by 100. If you divide it by 1,000, it's even smaller. There's ways of making numbers sound big. Anyway, I just want you to know that this is why we need calculus, because we need to be able to use numbers. We need to be able to actually give numerical values to things, not just sort of say it looks like that. All right. This is good though. Next post. Sebastian, what did you post? All right. 1 and 5. Okay, so this is less than 1% error. These are not changing by very much. That's also a slope that's pretty small. Because the number 0.6 is not a great plus or minus 0.6, 100 plus or minus 0.6. If you got 100 on a test and or you missed a question, you lost 0.6 of a point, it wouldn't mean much to your grade. All right, that makes sense. All right, next one. So the error in yours is very small. And the reason why your error is small is because your graph is not dropping really fast. The derivative is close to 0. Next post. Okay, Alicia, are you there?
Yeah.
Okay, Alicia's doing world population. And hers is very small too. The error is really small. Except not really. How big an error is it in 2010? What's your error?
It's like 39 million.
Okay, that's 28. That's 1980. But
Oh,
yeah.
sorry. It's 29 million.
So if that's 4 billion, then 0.039, which looks like 0, is off by 39 million people. That's a lot of million people. Isn't it? New York is not, how big is New York? New Jersey's only 7 or 10 million people. So that's off by a lot of millions of people. Okay. All right. Last post, Acacia. What's Acacia doing? Acacia, you here? What is this? Grade by studying?
Yeah.
And so look, at 13 hours, you're getting a 78 plus or minus 1.6. That's not bad. And that represents about 2%. It's like at 1.6 out of 78 is like 2%, isn't it? 1.6 is like 2% out of 100. So it's almost 2% out of 78 also. Okay. So your error is 2%. So you expect to get somewhere between 76% and 80%. Okay. By the way, saying error makes you sound smart. If you can say it, if you can give people error, it sounds smart. Because everything has error in it. And if you acknowledge that and give them some range as to what the error could be, it makes it sound like you're being transparent instead of just bullshitting. All right, let's keep going. Where are we now? Let's take a look at the what's my notes? Where'd they go? Here. All right. Let's move on to analysis functions. So let me ask some questions of you guys. I didn't change the questions this week, so I'm just going to use the same one I used before, which is here in mod 5. Okay. My class questions here. I still haven't done a new class question. So let's start with Slade. Slade, again, I asked the same question. Okay, if I'm asking you questions, be fast. The one thing I ask on this test is when you're asked these questions, answer them quickly. So Slade, how many points do we need for instantaneous rate of change? One. Acacia. Why did we invent limits?
To take the 2 points off the average rate of change to the 1 point of instantaneous rate of change.
Excellent. Justin, are you here? Justin is still not here. Cody, still not here. I'm just gonna start removing him. Eric, what's the derivative of a constant?
It's 0.
Very good. David, not here. Aiden.
Yep.
Product rule say.
Derivative of the first times the second plus derivative of the second times the first.
Very good. Selena, are you here? I don't think so. Good, because I don't get a question rules long. Garth, it's a derivative of EDX and derivative of natural log of X. No, look at me. What's the derivative of e to the x?
Derivative of dx, e power x
And what's the derivative of natural log of x?
is equal to e to the power x.
No, natural log of x.
Lx is equal to 1 over x.
That's it. Very good. Rudra, look at me. What's the derivative of sine?
Sin x equals to cos x.
Okay,
Derivative of
cosine is
cosine equals to negative sine.
very good. And what's the derivative of tangent?
And derivative of tan is
Say the word for it. Don't
gives the square.
see
Secant
can't.
square.
See
Secant
can't.
square, sorry.
See can't.
Yeah,
Who's your,
right.
you didn't have me for pre-calculus, did you? Secant is in pre-calculus.
Secant.
Okay. What does the chain rule say, Sebastian?
Derivative of the outside leaving the inside alone and multiply by the derivative of the inside.
Pam, what's the relationship between position, velocity, and acceleration?
The first derivative, and for like acceleration, it's the second derivative.
Excellent. Thank you. Jonathan, what does the mean value theorem say?
The derivative exists on AB so that it is equal to the average rate of change on AB.
I hope that you get that on the test. Pavani,
Me
are
too.
you? Pavani, are you here? Pavani? I don't know what happened to her. Alicia.
Yeah.
All right, what do we do if we don't have an explicit equation and we want to find the derivative? What do we do?
Implicit differentiation.
Very good. Carlos, are you here? Luke, what is acceleration?
Second derivative.
Second derivative, very good. All right, now let's move on to analysis of functions. So what's that mean, analysis of functions? So, oh, just as a quiz for everybody. Rudra, you're in this quiz too. What is 0 times infinity?
It could be anything.
Okay, Eric says anything, that's C.
Yeah.
You're saying 0?
I think-
George says yes.
I think
You say infinity, I have a 0 and infinity, anything, say anything. Sebastian, anything? Anyone else at home?
Anything?
Anything from, who said that, Jonathan?
Yeah.
Jonathan says anything, anything is winning. Anyone else say 0? Acacia, Alicia, Eric,
Anything.
all saying anything?
Anything.
I'll say 0 because that counts as anything, right? Well, no, I guess that's only one thing. I'll do anything.
Okay, that your logic is interesting. The answer is anything, could be anything. Look, infinity is not a destination, it's a journey. Do you know what I'm saying? think of infinity. It's the biggest number you can think of, and then bigger. So you have to keep thinking. So it's a journey to get to infinity. Zero, everyone thinks zero is a destination. It isn't. It's a journey. Okay, you can't really get to zero easily. And think about something like if I cut your salary in half, but I double your salary at the same time, aren't I just basically leaving it the same? Okay, but if I cut your salary in half and then quadruple it, and then I cut it and I quadruple it and I cut it and quadruple it, eventually you make a lot of money. So you take a half a cut knowing that the next day it'll be quadrupled. So it's definitely worth it. But what if that's one journey that goes to infinity. So the halving is making you go to zero. The quadrupling is making you go to infinity. But mixing them together, you end up getting infinity. Cutting in half and doubling doesn't change anything. Cutting in half, let's say I like to think of a spouse who spends a lot of your money. Okay. And you make more money, but while you're making, let's say 10% more a year, they decide to spend 20% more a year. So what's eventually going to happen to you? Maybe you'll go bankrupt. The journey is to bankruptcy. So you're going to zero. If you're losing more than you're gaining. So exactly how do we deal with this? So really it's how fast the journey is. So what they do in L'Hopital's rule is you're using L'Hopital's rule to answer. So the question is, what's the rule that we use? L'Hopital's rule. So L'Hopital's rule, we're looking at how fast you're going to that journey. So how do we measure how fast what tool do we have in our toolbox? Okay, let's put it this way. Calculus is the study of what? Change. So rates would be a calculus thing because that's how fast something's changing. If I'm asking how fast your journey is going to zero, and I ask how fast your journey is going to infinity, aren't I asking about those rates? I'm really asking about the derivative. So L'Hopital's rule just says, if you have a 0 over 0 or infinity over infinity, it says just take the derivative. How fast are you going to 0? How fast are you going to 0 in the denominator and compare them? And you just keep doing that until you don't get a 0 or infinity. You get a number. That's what L'Hopital's rule says. All right. That makes a lot of sense if you think of this as derivative. But please do not tell me that 0 times infinity is 0. That's the worst answer. I'd rather hear 3. Infinity is the next worst answer, but at least it's not 0. Okay. But as for finding limits, we're using, because we care about how fast your journey is going to 0 infinity, we're using derivatives to figure out what a limit would be. So we invented limits to find derivatives, and now we're using derivatives to find limits. Okay, it seems wrong, but it isn't. For some reason, it's not wrong. Okay, I'm done with L'Hopital's rule. Now let's talk about analysis of curves. Okay, I like this chart because it's, so let's look at this. So first of all, I have a graph, this is some sort of regular cubic equation. It looks like an S. Okay, sideways S. All right. I'm going to get myself a pointer here. Here's my pointer. All right, so here's the S. Do you see, does everyone see that S going like that? Whoop. Inside. Now, what I've done is I've said Y. I want to discuss what Y is doing. So that's the Y values. All right. You see that at this point right here, I draw a line down. Do you see how I put a 0 in that box? Because that's where the function is 0. And over here, there's another 0. So put a 0 in the box right there. Then I go over here and I put a 0 there. Okay, so that's the zeros of the function. That's a pre-calculus thing. Here, the function is positive. It's above the x-axis. So I put a little plus there and I say it's above the x-axis. Here, it's below the x-axis. So I say below and I put a minus because the values are negative. Here, it's above, so put a positive, and then there it's below. So understand that's just pre-calculus, nothing new there. But I just want you to see, I'm using pluses and minuses and zeros, and I'm talking about the terms I'm using are above and below. Above and below the x-axis. Right, now, the next thing is, let's look at the red stuff. See the red? Now put a little prime there, that's a derivative. So now I'm asking about the slope of the tangent line. Here, in this first region, you see it's going down, it's decreasing. So I say it's decreasing, but the slope of the tangent line is negative. Okay? When I reach the bottom, you see that red line there, it's horizontal, so the slope of the line there is 0. That's a minimum. Okay? And then it increases, so the derivative is positive. And then it reaches a maximum. We'll call it a maximum. And you'll see that the derivative is 0. So the derivative is 0 at maximums and minimums. It's positive when it's increasing. It's negative when it's decreasing. Everyone understand that? That's what that means. You've sort of done it with the project. When we were discussing stuff, you'd say when the derivative was positive, I'd say it's increasing by. The grade is increasing by 3% per hour or whatever. That's about as positive. The next thing we had on that chart was the second derivative. Okay? And the second derivative is just the derivative of the first derivative. If you have something going from negative to positive. So let me ask you something. Suppose yesterday was a bad day. And today is a good day. So you went from negative to positive. Did that change, was that change positive or was it negative? Went from a bad day to a good day. Wouldn't you say that was positive? Yeah, so you're accelerating, your life is accelerating, and that's positive. Okay, what if you're driving and you put your increasing, you're speeding along, and then you slow down? Are you accelerating or decelerating? Decelerating, in which case the second derivative would be negative, because your derivatives are going down. Does everyone understand that? Now, what about that point right there where it changed from everything here goes from a plus to a negative, and in between there's a 0. What happens there? What happens at that 0 right there? First of all, it's going to be 0, but what happens there? Okay. What?
Okay, I would say there's basically a constant. There's no acceleration or no deceleration.
Yeah, at that moment, so notice, let me see if I can do this. I want you to notice that when it's accelerating, it looks like the letter U. See this right here? Oh, you see how this is like the letter U?
Yeah.
With the concave up. And over here, when it's decelerating, it looks like the letter N, so it's concave down. But right there, it's switching from up to down. And it has a name, it's called an inflection point. Let's move along here. So here it is on Desmos. Here's one on Desmos that's nice and neat, where I've labeled all the zeros. And Desmos will find zeros and maximum ends very easily. Okay? So it found the 0 at -5. It found maximum at -2, found a minimum at 4.8, and it found it has a 0 at 7 and a 0 at 2. Okay, so the function is -0, +0, -0. The derivative goes increasing, so this function is increasing, then decreasing, then increasing. But if I graph the derivative, it doesn't look anything like the function. This is a graph of the derivative. But I want you to notice here, the derivative is positive. In the first region, the derivative is positive. Let me light that up. So here, the derivative is positive. So the derivative would be increasing. The function would be increasing, not the derivative. The function is increasing because the derivative is positive. Here, the derivative is negative, so the function is decreasing. And then over here, it's positive again, so it's increasing. Okay? Now, if something goes from increasing to decreasing, so if your day is getting better, and then it starts to get worse, what happened at that point where it changed from getting better to getting worse? Did you reach a maximum or did you reach a minimum? If you're going up a hill and then you start going down a hill, did you reach the maximum? Was that the top of the hill or was it the valley? Was the top of the hill?
Bill.
What about over here? What if your life is getting awful or you're going down the hill and then you change to going up the hill? And when it changed, was that the valley or was it the top of the hill? You went down and then you went up. What is it, maximum or minimum? The minimum is a valley. Okay, so you have to understand that where these zeros are for the derivative, those represent maximum minimums. And if you see positive numbers going to negative numbers, you know it's a maximum. That's something called the first derivative test. You're just looking at the first derivative and determining if it's a maximum minimum for the first derivative. That's the first derivative test. Okay, the second derivative looks like this. For this prime function, there's a second derivative is 0 at 1.33. And then there's no maximums here. It's just going from negative to positive. So it's concave down to concave up. And right there at that 0 is called an inflection point. So it went from concave up to concave down. Second derivative was positive. Now it's negative. That's called an inflection point where they change. Okay. Oh, here's the little down, the little DOWN, and the U. Okay. Critical points are defined to be any point on the graph where the first derivative is either 0 or undefined. Got it? So critical points could be max and mins, or they might not be. So derivatives equal to 0 on regular curvy functions look like that. But on a corner or a cusp or an asymptote, those things would be undefined. Okay. Let me quickly go back to my, where's my, hold on. Okay. Question for you. Do you see a max or min on this graph? You see a minimum. Is that a critical point? Is the derivative equal to 0 there? It's undefined. Okay. There's no tangent line here. It's equal to 0, could be anything. Okay. All right. So critical number. What are you playing over there that I can hear from way over here? Critical number is when the first derivative equals 0 or is undefined. Okay. So here, that's a critical point because it's not, the derivative is not defined. Let's try another one. Okay. Right there. Critical point or not? By the way, critical number here would be x equals 0. X equals 0. How about this one? Is that a critical point? What's the derivative at x equals 0?
It's 0, right?
Not 0. What's the slope of the tangent line there? It's vertical. What's the slope of a vertical line?
Undefined.
Right.
Defined. So that's definitely a critical point. But is it a maximum? No.
It's like dead center.
It's a critical point, but it's not a maximum. Does everyone see that? I'm just asking you, is that a maximum minimum right there? No. So it could be, so if it's a critical number, it doesn't have to be a max or min, but it could be. In the absolute value, it was. In the cubed root, it was not. Okay? Okay, another one, yeah. All right, so now let's look at the square root. Okay. Is that a max or min or a critical? Is that a critical point there at 0?
Yes.
It is, because the derivative is not defined. Let me just take the derivative and show you what. Oh, hold on. I can do the square root. I'll have to call it g of x. So if I take g prime of 0, see, it's undefined. So it's undefined at 0, but it is a minimum. That's the lowest value. Square root can't be any lower than 0, right? Square root of any number has got to be 0 or something. Okay. All right. Any questions on that? Critical number. Now let's talk about the other one. So critical number is there. So now let's talk about inflection point. Inflection points are defined differently. Okay, so a critical number, the definition of a critical number is derivative is 0 or it doesn't exist. But the max and min is very clear. You know what a max or min is. You can see it. Max or min. So critical numbers are this big group, and max and mins fall are a subset of them. Or they should always be a subset of them. There should never be something that's a max or min that isn't a critical point. Okay, now. All right, let's talk about inflection points. Inflection points are a little different. I don't care with an inflection point. I don't care if the derivative equals 0 or it's undefined. That's the bigger set. I don't have a name for it. So the inflection point is like the maximum. It's like a name for a very specific thing. An inflection point is when the concavity changes, or the second derivative, or the sign of the second derivative changes. So it has to go from positive to negative or negative to positive. It can't go from positive to positive. Okay? It's not an inflection point if it goes from positive to positive. All right. So does this one, let's just talk about this one. Does that have an inflection point? What's the concavity? The concavity is 0 everywhere, except it's 0, or it's undefined. It's pretty much everywhere. So this has no concavity. This has no inflection points. How about the cubed root? Does that have an inflection point? By the way, the first derivative is undefined at 0. The second derivative is undefined there too. Okay, there is no place where the second derivative is equal to 0, but there is a place where it's undefined. But is that an inflection point? Does it change from concave up to concave down? Do you see this? Sebastian, do you see concave up here? That's a letter U. See how it's shaped like the letter U? Okay. Rudra, do you see that this is shaped like the letter U? It's a piece of the letter U. I think it's the letter U. Like that. And then you see this one over here? Is this shaped like the letter U? I don't know. It's shaped like the letter N. It's a down. So this goes from up to down. So that point right there is an inflection point. Okay? Okay, square root. Is there an inflection point here? No. It's just down everywhere. All right. So critical points are when the derivative is zero undefined. Max and mins are max and mins. Inflection points are when it goes from concave up to concave down. So this is a slightly different thing. Desmos does not find inflection points for you. You understand? If I put in a graph of something, let me just put in a graph of something. Okay. You just wrench this a little bit. Okay, so there's a graph. Well, let me just make it a little smaller here. Okay, nice graph, right? I can just click on Desmos and find the zeros. 0, 0, 0, max, min. Got it? Are we good? Where's the inflection point? Is there an inflection point? Do you see an inflection point? Over here on this side, on the left side, is it part of a U or part of an N? What is this? This is part of an N. What about over here? The right, it's part of a U. So somewhere in this area it changed from going down to up. How can I get Desmos to find that? One way I could get Desmos to find it. Okay. Let me use h of x. I can graph the derivative. We did this with, remember when we did the mean value theorem, we graphed the derivative? Do you see the derivative is in green now? So the function is in blue. The derivative is in green. What does Desmos find for you? Easy. Zeros and what? Zeros and max and mins. Here's a 0. Here's a 0. Do you want to notice something about this 0 right here? It's at the same spot as the maximum. Look at them. The x values are the same. What about over here? Same thing. X values are the same. So the zeros of the derivative are the max and mins of the function. You got that? If I write h prime of x equals 0, it will find those two values. And I can write them down in a table. If I have, let's say, a table, and I put h of x1 here, h of x1 here. Okay, if I put those values, so I have h, and then hold on, to h prime. So there's h. Remember, you guys had h. You had h prime, and you had h double prime. This. Okay, so watch this. I plug in a value. What did we say that value was? 0.08167. So take that value, copy it, put it here. And look what it says. The function is 30. But this right here, 5 times 10 to the negative 5th, what's that number supposed to be? What's the number supposed to be? Sebastian, what is 5 times? Oh, I'm not going to pick on you, Sebastian. Let me find somebody from home. Acacia. No, I picked on you. No, that's fine. Acacia. 5.
Yeah.
What is that supposed to be? If that's a maximum, and what's the derivative supposed to be at a maximum, and why is Desmos telling me this? What's the number supposed to be at a maximum? The derivative is what? Slope of the tangent line is what? Begins with the z.
0.
That's it. supposed to be 0. So you have to look at that and say that's 0. The second derivative is negative because it's concave down there. All right. How about this one right here at 4.08? I'm going to pick on somebody else this time. At home. I'm going to call on Luke. Hello, Luke.
Hello.
At 4.08167, what is the derivative supposed to be?
0.
You see, so that's close to 0. And what the fact that the second derivative is 12, that's positive. That means it's concave what? Positive
Up.
number. Concave up, like a smile. Is that a maximum or minimum at that value right there? 4.08, maximum or minimum?
Minimum.
It's a minimum. So a smile has a minimum. That's the most confusing part. It's the derivative, it's the second derivative is positive. It's going to be at a minimum. All right. Very good. Thank you, Luke. All right. I still don't have the inflection point. How do I find the inflection point? Okay. What am I graphing? Let me go back to the derivative for a second. Here's the derivative. What does Desmos find easily? The zeros, I found them there and there. What else does it find? This is the graph of the derivative. What else can I find by clicking? Garv, what can I find? What else can I find from this graph? I have these two zeros. And don't tell me y-intercept. I don't care about the y-intercept. Where else is there a gray dot on that green line that I can find easy?
Yeah, 2.
At 2. And what does that represent? Is it a maximum, a minimum? It's a minimum. 2 is a minimum. But when I plug it into my graph, my thing here, look what it gives me. When I plug 2 in, the function is 12. It's decreasing, but the second derivative says 0. So if the second derivative is 0, it's probably a what point? I solve for the second derivative equals 0. Second derivative equals 0. You see it happens at 2. Okay. What is the second derivative? When that's true, what did I just find? Let me go back to the original graph. Where's the original graph? Here it is. Here's the original graph. What's happening at 2 right there? What's happening? It's not a maximum. It's not a minimum. It's the thing we were looking for. What are we looking for?
Inflection point.
Thank you, Christian. Inflection point. That's the inflection point. That's where it changes. Look at it. It's looking like an N, and then it's looking like a U. And right there is when it changes. All right, we found that by graphing the derivative and finding it. So what did we exactly find? Well, we graphed the derivative. This is when the derivative of the derivative equals 0. That's the second derivative. So that's what it is. It makes perfect sense, and that's how you can find it. Okay.
I watched.
All right. There are 2 tests for finding maximum values. I don't really care too much about them. The first derivative test is just to look at the first derivatives. So, for example, in this problem, if I have a number like minus 0.08, let me put some points in here. Okay, so I'm going to do this. The number is smaller, 0.09 and 0.07. So let's take a look at the derivative. So I'm going to just look at this point. I'm just going to look at these 2, right? So the first derivative test is a test of the first derivative. So all I'm going to do is look at the first derivative. Here's the first derivative. Oops. This is the first derivative. That's the one I'm looking at. 2. And you see it's going from a positive number to a negative number. So what does that mean? It means the derivative was going up and then the derivative is going down. So what does that tell you happens at where it's 0? So here it's 0. So we know it's a max or min. If it was going up and then down, is it a maximum or a minimum? Up and down. How about Alicia? What is it? Is it if it goes up and then down, is it a maximum or a minimum?
Minimum?
Really? Up,
Sorry, maximum.
it's a maximum. So that's what the first derivative test tells us. If it went from positive to negative, it was going up and then down. Okay? Let's try the other one. The other number, which was, what's this one right here? 4.08. So 4.08. Okay, let's do 4.07, 4.08, 4.09. Okay, so in there, it's going from, it's because this number is, because that's negative, it's going down first, down. And then because that's positive, now it's going, that number there is positive, it's going up. So is that, if it goes down and then it goes up, is it a maximum or minimum? Down and then up. Anyone?
Minimum.
Minimum. That's the first derivative test. All right, now, what's the second derivative test say? The second derivative test uses this same chart. But it says this. It says, I know this. Where's my squiggly line? I know this is a 0. But I know that the second derivative is negative. So is that concave up or concave down? Negative. Second derivative. It's down. So is that a maximum or minimum? If it's concave up, if it's a sad frown, is it a maximum or minimum? Hello? Jonathan, is that a maximum or minimum?
It's maximum.
I didn't get you. It's
Maximum.
maximum. Very good. Because it's concave down here at the maximum. Here, the derivative is 0, but the second derivative is up. So that's a what? Say it.
Minimum.
Okay. So how is that actually done? You could do it algebraically. Back in the olden days when you couldn't see a picture, they would do it algebraically. Let's see. See, like this guy right here, they'd say, where's the maximum for this function? They take the derivative, they'd set it equal to 0, and that would give us our 2 critical points, 1 and -1. And then they would take the second derivative and they'd say that's 6x. And then you would plug this 1 into it, and you get a positive number. So that means it's a minimum. And you would put -1 into it, that would be -6, and that would be a maximum. And that's how we did it algebraically. But you don't have to do it that way anymore. Honestly, you do it only that way if the algebra is easier than the graph, but mostly the graph is easier than the algebra. All right. So we're going to break up into our groups now, I think. And we're going to work on our regressions. But please note, one of the groups, did you guys do exponential regression? So a linear regression doesn't have any critical points or inflection points, just a line. It's like, no. An exponential regression, same thing. It has a curve. Actually, it has a curve. So it's concave. But it doesn't change concavity, so it's no inflection points and has no maximums. So the exponential regression is going to be a problem. Logarithmic is same thing, except it curves this way. No max or mins. No max, mins, or inflection points. The sign regression is equally useless because how many max and mins are there on a sign regression? Here's a max, here's a min, here's a max, here's a min. There's an infinite number of them. And it's going concave down, concave up, concave down. So there's an infinite number of inflection points too. So sign regression is not great either. Quadratic has one critical point, one max or min, and it has no inflection points. Cubic has an inflection point, but maybe no max or min. If it goes down like up and down, it could have two max and mins, but it doesn't have to. It could be like a jig, in which case it has no max or min. Quartic definitely has a critical point. Quartic one, no matter what you do with a quartic, you always start and end up or down. There will definitely be a critical point, but there may not be an inflection point. Okay? So y equals x to the fourth, for example, has no it has no critical point. Right? It has no inflection point. All right. I think I'm losing you, so I'm going to just let's stop sharing. All right, let's get into our groups. What you're going to do is you're going to fill out a table. Okay, we can use the table to figure stuff out, but if you have a quartic regression, you're going to need to find these inflection points and critical points. Okay, so when you break up into your groups, make sure you find them. How are you going to find them? So when you go down to, this is what I recommend. So pay attention, because I'm going to break up into groups and we're going to work on, this is mod 7 now. We're going to go to analysis of functions. And you're just going to turn on the derivative like that. And you're going to look for the zeros and the max and mins of the derivative. And then you're going to take those numbers, producers, you're going to take those numbers and you're going to put them into your table. Minus 3.842 something going into the table. Putting it in the table. Maximum, minimum, putting this one in the table. Oops, is that 2.5? Okay, and how about this one? 13.333. So they have to be in the table, and I want you to see something. When you put them in the table, I don't need anything else in the table, nothing else in the table. Okay, but I'd then turn the derivative off. I don't need the, just like with mean value theorem, I don't need it anymore to take the rest. So there's my graph. Okay, and because I put it in the table, you'll see that I can get the points. There they are, green. Do you see this green point right here? That's what? What would you call that? Sebastian, what would you call this? Minimum. Garf, what would you call this one right here? It's not a maximum, it's not a minimum, it's another what? The second derivative is 0 there, so what is it? It's with an I. Inflection point. We pick on somebody else. Pam, where's this? What is this green point right here? At 13.333. 13.33. The derivative is, second derivative is 0. So what is it? Okay, so you have to say, so the writers are going to write this. When it's a minimum, this value right here is supposed to be 0. So for the minimum, you have to say the derivative is 0 and the second derivative is positive. Okay, second derivative is that right there. That's a minimum. Inflection points, you're going to take the second derivative. Oops, just cut this off. So it's just the second derivative of 2.5 is 0 and the second derivative of 13.33. So those are inflection points. Okay? Do you guys know who does the writing in your groups? So that's what the writers are going to write. know what the speakers are gonna do? They're gonna say, according to the Portic regression, there's a minimum at 3.8 hours. Oh, at minus 3.8 hours. And there are two inflection points at hour 2 and hour 13. Okay? That's what I want to see. And by the way, if you have a group, I've decided I'm going to change my rules. If you have a group, you need a producer and you need a presenter. Okay? So if there's only 2 people, you need one that someone should write. Or somebody should, not the writer, somebody needs to be speaker. The last thing I need is the writer. That's the writer. So give that to somebody who isn't here. But if you have, let's say, 3 good people in your group, somebody produce it, somebody do the speaking, and then somebody say the speaking, and then if you have a voice person, let them do the writing. Okay? That's what I want to see done. All right, let's break up in our groups and work on this. Okay? You know what groups you're in? So like Jonathan, you and Acacia are your own group, right? Just 2 of you?
Yeah.
So whoever produces, and then the other person should just right away go to a video and say what they want to say. There's a maximum here, there's a minimum there, there's inflection point. I want to hear where the inflection points are.
Okay.
Everyone should have an inflection point and a max or min, at least one of those. If you don't, raise your hand and I will come and I will help you find a way to find something. Okay? All right. So I have 4 groups here in this class, yes. Remember what group you're in? Join the group that you're in. Aiden's in 3. So Sebastian, you want to join 3? Who's in your group besides the 3 of you?
Selena, but she's not on the call.
Oh, good. Then you don't have to do any. You can just do it here. Stick her with writer. Acacia, what group are you in?
2.
Okay, there you go. Off the 2. Eric? Are you in room 4? Alicia's already gone. Sakla and Christian are online. Pam, what group are you in?
Group 4.
Off you go. Avani, what group are you in? Who are you with?
Group 4 as well.
Okay, there you go. Off you go. Aiden and Sebastian, there's nobody else for you. Christian and Sala, you can do whatever you want. I have to do something. I have to create the group 7. What happened? Who, in this class? What happened to your grade?
Yeah, got a B.
On what? After something was due?
Oh.
Are you looking at the stupid percent? Don't look at the percent.
Oh.
I don't know what the percent means on Blackboard. I tried to get rid of it, but if something opens up, your grade will go down. Like if something, or it's not to opens up, if something closes that you didn't finish, that I may not even be counting, but it might be there for some reason, then it makes your grade go down. Your percentage goes down. But your points are basically out of 1,000 points. I mean, the total is you have to reach whatever 700 points to pass the class, or 650. Okay.
But I had a B, I checked, but last night it went to 69.
69 still passing.
It's passing, but I can't transfer.
It transfers.
Not with the D, it should be a C.
No, it passes and transfers because in my class is 65, it's a C.
Oh, good.
So, but don't you dare come arguing if it's a 64. The only reason it's a 65 is because I'm tired of hearing people complain between. That's all I get. Please let me do 1 point. So it's no. You get a 64, you get a D. But if you get a 64.5, then you can have a C. But then we don't talk. And then we don't talk. We don't bother me. Don't say, well, how far away from a C plus am I? Because you're really far away from a C plus. But I'm gonna be. But don't be messing with me. Yeah, I always make 65, but this was a hard class. 65 is fine. Let's see. I don't need you arguing with me. C basically means you filled your requirement. Now go away. If you can get a 65, then you probably did do your requirement. What am I looking for? Analysis function. Are you guys working? You're not making any noise. You're my group that's here. I need to hear you talking.
Yeah. Make sure that you post a screenshot,
Oh, okay. So you already done? You're waiting for this?
yeah, and then I'll show them the.
All right, it's done. It's done. It should be there. Sebastian, you have a problem.
Yes, because mine isn't, like, it doesn't go.
What? Yeah, because I told you can't use exponential.
So
Rob, to go back to another regression. That's good. An exponential regression. So
If our thing,
can you go up to the top of the functions? It changed. Yeah, so up there. Yeah, so you made this function, this Q of X. So why don't you do a different one? Let's go after this one, hit return. After this, hit return. Put the line 6. You can leave your exponential. I just don't care. Say hit return. Now do y1 approximately equal to, there's just this tilde right up there. And now we can this is so potency, right? But it keeps just going down.
well, I have this one which continuously goes up, and then I have this one.
Yeah, that one doesn't help. They're both terrible. Let's try cubic and see. So try A x1. So type an x and 1. No, sorry, raised to the third power plus B x1 raised to the squared power plus C x1 plus D. Okay, now I'll zoom in on that. It looks better, but it's not necessarily better. Wait, oh yeah, look at that. I think I see a max and then a min and then a function point. So let's go down here. Go down. So in order to get the function, you have to turn them both off. Oh, just turn off the folders. That'll turn off everything. Like turn off those folders there because it might be on somewhere. Okay, so now this looks promising. Where's what's his name? Is he around?
Aiden.
Can you hear us, Aiden?
He's on Zoom. Currently.
Why did you mute yourself? He could hear us. Aiden, are you there? Unmute. Aiden, can you hear us? No, well, I don't care. Can he hear you? Is he saying yes?
Yes.
All right, Aiden, so share screen and show him what you're doing. So Aiden, Sebastian asked me to help him and I helped him. We went back to a cubic regression and there it is in blue. Okay, so now, that's fine. What you need to do now is to graph the derivative, which you did. That's that purple line, but you can barely see nothing. So what I'm going to recommend you do is go up to the wrench. Okay? And ask for Y values that are really like minus point. So go here and change it to a really small number, like 0.5 or something. Minus 0.5. And other you go to plus 0.5. What that's gonna do is it's gonna blow up that now, can you make it? So just do that. Yeah, there we go. That's what I like. Okay. So that purple line is the derivative. Keep going. Mhm. So we're looking for, nope, not too far out. Okay, but we're looking for the we're looking for the, wow, we're looking for the x-intercept. There's gotta be an x-intercept and a max and min here. I just can't see it. It's in there somewhere. See, this is minus 0.1 and plus 1, so up to the wrench, change this. It's smaller, 0.1 and minus 0.1. Minus 0.1, and then the other one is 0.1. You see a zero in here somewhere? My God, you're killing me here. Yeah, that's good. Let's do this. And can we make this? What numbers are we looking at? 600? This range. So it's somewhere in this range. I just would really like to see it. And by making it as small, I can zoom in on more. But I feel like I need. Are you guys okay?
Yeah.
Not know what to do here. Back to, can you go back to the graph itself? So you turn the graph on. Go back to the page, then give it your- That's the blue one. Oh, it's still on. So just. There's the blue graph. All right, so here's what you have. Just click, that's your maximum is at what? Minus 3.2. Where's your minimum? Right here at something. There's your minimum, or 0.7. Got that? So there's your maximum and your minimum. Your inflection point is somewhere in here. Can you just take this function? Did you make your function? You didn't make that into a function? Did you have the derivative, right? No, the derivative isn't helpful. Maybe it is. We'll zoom out. We're looking for the zero of the derivative. So that's we're not looking for the derivative. That inflection point is going to be the maximum of this graph, and I can't even see it. All right, so this is what we're going to do. We're going to do this. Change this function after this point here. Right, c of x equals c of x, and then just copy and paste that whole thing in there. Just type in ax cubed plus bx squared. You have to get rid of the ones, but you can do that, yeah. Get rid of the ones. Get rid of the one. Get rid of the one. You have to get rid of that spot. Okay, good. Now that's why did C is a function, try using C is a function. Okay, so what's wrong with that? Try using a different letter besides C. You probably use F. You haven't used F anywhere? Oh, then try it. Alright, so now what we're gonna do, so there's the function in green. So go to the next line. Can you hear us here, Aiden? Just type in f of x equals f double prime of x. What's your problem? Double prime, the double prime that's correct is not that double prime. Equals 0. All right, so why is it? It says you divide f. So make that f1. Okay, there it's right there. Oh, make it that. No, make that f1 because that's not. Oh, there we go. So that purple line is where your inflection point is.
Okay, so now for the graph.
There, see it's 0.77.
Okay, so I just need max min and then the inflection.
So all this, take a picture of that, but you need to put those points in your table.
Alright, okay.
Okay, that was painful. But because your exponential doesn't have any of that, it just goes, which makes more sense, but you can't do what I'm asking you to do is find maximums and inflection. So now you can. Okay.
Like, I got like, F prime side phi equals to 0, F double prime. Sine phi equals to plus 0.0.
Yes. In short, if you're the writer, I always want to see the units. So if it's a double prime, you're gonna say, what is your stuff? What's your topic? Something per something per something. No, but what's the topic? What are you talking?
BFF and,
So just say BFF, so at the end of there, say BFF. Per. K. Per K. Okay.
same thing over here.
Here, you put those units there, and then for the first one, you say. When 0 BFFs per K, just one. So copy and paste them. You copy and paste just the first group, you don't have to type them.
Good, right?
That's it. You should put a space there, but that's what I do. Who else do we got here? Alicia, it's vacation. You okay? Did they all leave?
Yep.
Oh, that's nice. Oh, what the heck is this? That's not good. Class. All right, I don't need that. I do need that.
Professor, I don't know if you're trying to talk, but you're muted.
I am not talking,
Okay, I'm just making sure.
but thank you. I appreciate the reminder, but no, I'm not talking. Okay, just cleaning up here. All right. So it's 7:30. I got a little bit more to finish up here. So let me go over a couple of things. First of all, the class discussion questions. What is 0 times infinity again? Anyone?
Could be anything.
Could be anything, right? And how do we find it? We use L'Hopital's rule. Okay. When can we use L'Hopital's rule? When what?
When there's infinity over infinity or 0 over 2.
Very good. Acceleration is the what? What derivative? Anyone?
Second derivative.
Inflection point is when the concavity changes, and critical numbers are when the derivative is 0 or undefined. Okay, so those are the terms that we need to know for next week. Now we've covered them. All right, so this is the homework. These are the homework questions you have. Homework 5. Wait. Oh yeah, homework. This is homework 5. Homework 5 is done. Okay, so if you have any of these questions where you're asked to do the limits, you could certainly do the limits. You can plug in points, you can read the things, you can see the L'Hopital's rule. I would read them because they do show up on the tell. I would make sure I can read these. So like, all right. So now some of the questions are determine where the graph is concave down. So concave down means, so here's the graph. Let me just do this. So here's the graph. I don't even see the graph. There it is. That graph is crazy talk. Let me see. Is there other graph? Oh, there's another graph up there. Okay, so this graph is really hard to see. Okay, and I can sit here and I can fuss with it to make it more visible. Well, let's say 2, 2, 2. There we go. That's a nicer view of it. Okay, that's a nice graph, but it took me a while to figure out that. You could mess it up. But it asks you this question. It says, when is it concave? When is the graph concave down? It looks like it's concave down all over here and not over there, so to the left and not to the right. But you could just literally write in Desmos, the second derivative is less than 0. That will give you, and then if you turn it on, it'll shade that region. Okay, you'll see it found the inflection point at minus 6.5. And then everything here is when it's concave down. So that's really easy. If you know what you're doing on Desmos, I'm perfectly okay with that. You don't have to do the algebra. That if you click on the answer, it'll show you how to do the algebra. Okay, here's another function. And they want to know use the second derivative test to determine the local extrema. Oh, okay, with that one, you're gonna have to look at the explanation on how to do the second derivative test. But I only see one, looking at the graph, there's only one minimum. There's no minimum over here. It's just that one minimum. Okay, so you're gonna set the derivative, set it equal to 0. So to do this, you take the derivative, okay, which is this, and then you can factor it if you want. And then you set it equal to 0. So when you set equal to 0, either that's 0 or this is 0. Well, 0 is not one of the things we care about, so it must be the other one where 4x plus 15 equals 0 gives us that number. Okay, then you take the second derivative by just taking the derivative of, so that's 12x squared, and that's 30x. That gives you the second derivative. And then you plug in minus 15 over 4 into that. And you show, if I just do this, I think, do that. Yeah, it's a positive number. So since it's a positive number, it must be concave up. And that's all you have to do for the second derivative test. All right, what is this? I don't know what that is. That's garbage. What's that doing in there? It's garbage. I'm not getting rid of it permanently. No, I'm just getting rid of it now. Okay. All right. So next question is, where is this concave up and down? Again, if you want to know when it's down, it says, let me turn this one off. That's off. So if I want to know what's up, it's up. There's the graph of it. It looks like it's concave up everywhere greater than 0. So, and it is. Okay, so it's everything bigger than 0. If you're not sure, you can zoom in. Maybe it isn't everything greater than 0. Looks like everything greater than 0. Okay, if you want to, you can actually do the second derivative. Huh? You can see it done there. Same thing with this one. Let me just turn these off. It's the same sort of thing. Here's the function. And you want to know when it's greater than when it's concave up. So you want to know when it's greater than 0. It's greater than 0. That's when it's concave up. And everything in the middle is concave down. Okay. So the homework isn't too bad. Use Desmos. Make sure you know how to use Desmos. This came from the quiz. They asked, so in this first one here, they're clearly using L'Hopital's rule. Okay, they're taking the derivative of the numerator and the derivative of the denominator because they got infinity over infinity. So that's L'Hopital's rule.
I have one question about that.
Yeah.
So the derivative of that is infinity over infinity again, right?
Well, this gives you infinity over infinity.
Yeah,
So-
and then the derivative gives you infinity too, right?
You're saying they didn't do anything actually.
No, I was just because this was on the homework,
Yeah.
and like when you get that, that's infinity over infinity, right? Again.
Uh-huh.
So when you take the derivative of that,
Again.
oh wait, actually, sorry, I'm thinking of a different question. Never mind.
No, but if you get infinity over infinity. So if you take the derivative again, if you take the derivative, okay, I can do this. I can put the derivative there, and I can put the derivative there. Okay, and what am I going to get then? I'm going to get
1/2.
4 over. Yeah, I'm going to get 4 over 2 is just 2. That's all I'm going to get. It's 2. But that's using L'Hopital's rule again. I just used L'Hopital's rule once. So this is just using L'Hopital's rule at all. I didn't actually even finish it. Okay, I did L'Hopital's rule once. So the second one is I'm trying to find when it's concave down. This one here looks like L'Hopital's rule. This one here, I'm looking for when it's equal to 0, I took the derivative because I'm going to find the critical points. Here is L'Hopital's rule. This is L'Hopital's rule a few times. This one is, I'm trying to find when it's concave up. Second derivative positive is concave up. This one here is L'Hopital's rule. This one here is a second derivative equals 0. This is an inflection point 1. And this one right here is this one here is just algebra. I didn't do L'Hopital's rule. I'm using algebra to find the limit. Okay. It's still infinity minus infinity, so it's a L'Hopital's rule sort of thing, but I don't need to do L'Hopital's rule. I don't have a denominator. So in order to get a denominator, I'm going to multiply top and bottom by the conjugate, and then I'll have a denominator. But when I do that, I will do the limit, and I won't need L'Hopital's rule. So L'Hopital's rule will be for nothing. Okay? All right. So that's the homework. The quiz, let me just quickly look over the quiz and then I'll be done and I can let you go. Quiz 6. Did quiz 6 show up, by the way? No, it did not. Hold on. Went to 6. Hold on a second while I make it available. Multiple tabs. Take this next Tuesday, the 15th. Okay. Okay, so let's see what it looks like. Quiz 6 looks like this. What are critical numbers? Anyone? New to today.
The X values where the derivative is 0.
Very good, thank you. Okay, say this. Okay, so this is just a matter of saying a derivative, limit, blah, blah. I'm not going to do it. We went over all of these, whether they were concave up, whether they're concave down, whether we're looking for inflection points, algebra to find a limit, critical numbers, and L'Hopital's rule. Okay. Find the critical numbers of the function. Okay, so you can take this, go to the formula sheet, plug it in there. Okay, and the way you can find the critical numbers is by what? You can zoom out until you see it. Well, oh, I see it's the line. I forgot to raise that. Oh, now I gotta zoom back in. There's a critical number right there, minus 0.5. This is a parabola, so there are no other critical numbers. That's it. Okay. The next one. Identify the critical points. Okay, so this is when it's just a matter of finding the critical point. So this is a cubic. Okay, so here's the problem with this. I've graphed the derivative. If I want the critical points, they're going to be here and there at 13 and at 19. If I graph the function itself, you can see there's a maximum at 13 and there's a minimum at 19. Okay. Something else in here that I didn't like. Oh, I didn't care for question number 2, but I'm not going to change it at this point. So quiz this up and running. It's not my favorite because the say stuff in this section was how to say differentials and not limits, but limits are fine too. All right, done. Any questions?
And the last question, the question 4,
Question 4.
was, oh, you can't go back.
Can't go back, but I can try it again. Hold on. This is mod 6. Quiz. Again.
It was just finding the critical points, but I was just wondering how you would do it algebraically. Or like if you wanted to just find the first derivative.
Okay. So it's this one.
So-
Finding.
Yeah, so that would be second derivative, right? Inflection. So second is equal.
Yeah, but I can find the critical points the same way. I just need to find a Desmos sheet, copy it in. Okay, make sure that these are raised up. Okay, so how do I find them algebraically? I can take the derivative. So it would be 44, or no, 44, 66 x squared plus 16x plus 8. Now, if I want to do the credit, I have to set that equal to 0. So if I algebraically would be using a quadratic formula, if I do it with Desmos, I can do it that way. But I don't see, honestly, I don't see it anywhere. Okay, so if I look at this graph, it looks like there is no maximum. So that I set this equal to 0, I'll use quadratic formula, there won't be any real solutions. So what I'll do is instead of doing that, why don't I find the second derivative, which would be 2 times 66 is 132x plus 16. That I could definitely set equal to 0 and solve for it. But just the answer is just going to be what? Minus 16 over 132. Okay. So that answer is 0.121212 or whatever. Minus 3 over 44. But if I look at the inflection point, I can't really see the inflection point, but it's right there. Right, it's not there, it's minus there. It must be this one. There it is, minus 0.121212. You see how it's going from concave down to concave up, but very slightly. Okay. But I could literally, that's algebraic. If I just want the second derivative equals 0, I could just do that. And then click on that line and it's 0.1212. Okay.
Okay, thank you.
All right, take care. Have a good day. I took attendance earlier, so everyone can go. I'm turning off the live stream. Have a good night. Have a good weekend. I'll see you next week.
Good night.
See you. Good night, brothers.
All right, take care.